So, good morning students. Yesterday we were discussing about circles. We discussed about equal chords, equidistant from the center, and several number of theorems we proved. And we also proved the most important theorem. Yesterday we proved theorem 10.8 and it was extremely important as I said. Now today few theorems are there whose topics, whose concept we are going to use, we are not supposed to prove that. Alright. So for that please check your page number 183 of your NCERT book. Theorem number 10.11, 10.12. It is about cyclic quadrilateral. Quadrilaterals chapter we have just finished. We know what is a quadrilateral. Now comes cyclic quadrilateral. What do you mean by cyclic quadrilateral? When the four vertices of a quadrilateral are on the circle. When four vertices of a quadrilateral are on the circle, then we say it is cyclic quadrilateral. Can you see that? This quadrilateral is there and the vertices are A, B, C, D. All the four vertices are lying on the circle. So this quadrilateral A, B, C, D is a cyclic quadrilateral. Cyclic when all four vertices are on the circle. This is what we mean by cyclic quadrilateral. If I draw another circle and if I make this quadrilateral, the fourth vertex is not on the circle, say P, Q, R, S. The fourth vertex is not on the circle, it is outside the circle. So this is not a cyclic quadrilateral. What is a cyclic quadrilateral? When all four vertices are on the circle. I hope I am clear. Now, the property of cyclic quadrilateral, what is it? Opposite angles give the sum 180 degree. That is, check over here in the figure. Opposite to this angle A, which is angle C, angle A plus angle C is equals to 180 degree, and angle B plus angle D is equals to 180 degree. Angle D and angle B, they are opposite of each other. So this is what we mean by cyclic quadrilateral. We don't have to prove this statement. We don't have to prove the theorem, right? Application we have to do in this exercise 10.5. The only major exercise of this chapter is exercise 10.5, and it is very easy. As I said on the very first day when we started geometry, observation. If we can observe the things, it is easy. But if we are not able to observe the things, then it becomes difficult. And for observation, you need to recall all your statements from theorem 10.1 to 10.1111 and 1. Right? 10.11 says the sum of either pair of opposite angles of a cyclic quadrilateral is 180 degree. The sum of either pair of opposite angles A and C, B and D, they give the sum 180 degree. And 180 degree we know any quadrilateral the sum of angles is 360. Right? Then 10.12 converse of this, he says, if the sum of a pair of opposite angles of a quadrilateral is 180, any quadrilateral, if the opposite angles give the sum 180, then it is cyclic. So the most important property of a cyclic quadrilateral, that opposite angles give the sum 180. Clear, students? So that is what we mean by cyclic quadrilateral. And now we will discuss exercise 10.5. Very important exercise. The questions are asked from this exercise. And as I told you the very first day, the most important part is the theorems in this chapter. Alright, please check the questions now. Please check the questions. You will be able to identify which questions and which theorem is applied. Alright, take a look. Page number 184. Page number 184. Exercise 10.5. First question. I am drawing the figure for you, and then you can see, you can observe. This is the figure given to you. In the given figure, A, B and C are the points on a circle with center O. This is the circle with center O. This is point A, this is point B, and this is point C. Right? And you can see from A, it is joined to the center, B is joined to the center, and C is joined to the center. This angle is given to us 30 degree, and this angle is given to us 60 degree. So how much is the total angle? We can see that angle AOC is 60 plus 30. How much? 90. We can see easily. Then it says angle BOC is 30 degree, angle AOB is 60 degree. If D is a point on the circle other than arc ABC, this is arc ABC, D is another point over here, and then A is joined to D. D is somewhere over here. A is joined to D, C is joined to D. Yes, he says find angle ADC. This angle he wants us to find. What is given to us? We are given angle AOB equals to 60 degree, angle BOC equals to 30 degree on RABC, right? And angle ABC is also on RABC. Just check. ADC, is it also on the same arc? Yes. What we have to find? We have to find angle ADC. This is what we have to find. So very easy. If we can observe, turn around your page and see theorem number 10.8 of your textbook. Theorem number 10.8. What does it say? It says angle subtended by an arc at the center is double the angle subtended by it on the remaining part of the circle. We have proved in the last video, we had proved in the last class, yesterday itself. Yes, we know, you will have to write down the statement. We know angle subtended by an arc at the center is double the angle subtended by it on remaining part of circle. That is which theorem? Theorem number 10.8. So therefore angle AOC is equals to twice of angle ADC. Angle AOC is made of two angles, 60 plus 30. 60 degree plus 30 degree is equals to twice of angle ADC. 2 is in multiplication, 60 plus 30, 120. 2 is in multiplication, goes into division. Angle ADC. So therefore 60 degree is equals to angle ADC. Clear? Sorry, 60 plus 30, 90. I am extremely sorry. 60 plus 30, 90. So 90 by 2, 45 degree. Sorry for the calculation. 45 degree. Any confusion? This is what we proved yesterday. Angle at the center is double the angle on the circle. This is what we proved yesterday, and today we have applied it. Now that is why I said that it is very, very important that what are the theorems you should keep in mind. Take a look at question number 3rd, 4th. They are similar. Take a look at question number 3rd. I will discuss again, don't worry. Question number 3rd. In the given figure, angle POR is 100 degree. This is the figure given to us. Angle PQR is 100 degree. This is the center, right? And this is the line segment. This is the center O. This is PQR. This is Q, this is R, and this is P. This is 100 degree. And and we can see two lines over here. This is one line joining to the center, this is another line. So what is this OP and OR? They are the radius because O is the center. They are the radius. Can we see that? So definitely it is the radius. So that means in this triangle POR, these two sides are equal. So will these two angles be also equal? Yes sir. Angles opposite to equal, sides opposite to equal angles of a triangle are equal. We proved it. We had applied it in chapter number 7, theorem number 7.2 and 3. Sides opposite to equal angles. Observation. We did not write anything. It was an observation. Yes. So this is equal. So what is given to us? First of all, read the question. Given to us angle PQR is equals to 100 degree. This is given. What else is given? Where PQR are points on a circle with center O. Nothing else. What we have to find? We have to find angle. We have to find angle OPR. OPR. Where is this OPR? Let us identify. OPR. This angle he wants us to find. I call it as X. This was my observation construction. So let us write it down. Construction proof. In triangle POR, OP is equals to OR, that is the radii of the circle. Yes or no? So therefore, angles opposite to equal sides are equal. Therefore, angle OPR is equals to angle ORP is equals to X. OPR and ORP, both of them are equal. I call it as X. Any confusion? This was our observation. Now we see what? One angle is on the circle. Angle PQR is on the circle, and it is on which arc? This is the arc PR. Yes. And on the very same arc, there is another angle that is visible, but that is on the center. Where is it? POR. Can we see that? This angle, is it on the same arc PR? But it is on the center and this is on the circle. So again same statement. Angle at the center is double the angle of the subtended line. If this is 100 degree, how much will be this one? 200 degree. Now angle POR is twice of angle PQR. By which theorem? Again theorem number 10.8. Which is the arc? PR is the arc. Observation check. PR is the arc. One angle is POR here. Another angle is PQR here. So angle POR we do not know. Is twice of angle QPR is how much? 100. So 100 into 200 degree is angle POR. This angle is 200. But this is not what is asked. This is not what is asked. Then check this O. How much is the total angle? Complete angle we know. We all of you know how much is complete angle? 360. And O, complete angle is 360 degree. So therefore angle POR plus. Is this a reflex angle? We can say more than 200, more than 180 plus 200 is equals to 360. So therefore POR, in other words, here also you are writing POR, here also you are writing POR. Observe it. This POR is outside the triangle, that is the exterior angle, and this is inside the triangle. Right? So angle POR is equals to 360 minus 200. 360 minus 200 is how much? 160. Angle POR. This angle is 160 degree. And what is the sum of angles in a triangle? 180. And in triangle POR, sum of angles in a triangle is 180 degrees. So therefore, angle POR plus X is equals to 180. 180. Angle POR 160, x plus x, 2x is equals to 180. So 2x is equals to 180 minus 160. So x is equals to 20 upon 2. So therefore x is equals to 10 degree. That is angle OPR is equals to 10 degree. These all properties we have used in lower classes. Sum of angles in a triangle, complete angle property, we have used it in so many times in lower classes. Correct? The only new property was the observation of this 200. This angle PQR is on the circle and POR is on the center and the arc remains the same. Same type of question is question number 4. Please check. Again the same property is being used over there. Question number 4. It says in the given circle ABC, angle ABC is equals to 69. So this is A, B, C. This is C, this is B, this is 69 degree. Yes or no? Correct? And angle ACB is 31. ACB is 31 degree. Sorry, this is not 69, this is 69. Sorry, my mistake, this is 69. Complete angle is 69. Now check. Can you find the third angle? What is the sum of angles in a triangle? Right now it is. What is the sum of angles in a triangle? 180. Can I find the third angle of this triangle? Definitely, sir. Sum of, I have not completed the figure. I have just drawn according to the given quantities. What is given? We are given angle ABC is equals to 69 degree. Angle ACB is equals to 31 degree. What we have to find? We have to find angle angle BDC. Angle BDC we have to find. Now where is BDC? I have not marked. I am not marking also. Because I can see a triangle, can I find the third angle of the triangle? Not to worry what is being asked. Write down what you can see in geometry. It is very, very important to write down whatever you are able to visualize, whatever you are able to see. Sum of angles in a triangle. In triangle ABC, angle A plus angle B plus angle C is equals to 180 degree. So angle A I do not know, but angle B, how much is angle B? 69. How much is angle C? 31 is equals to 180. So angle A is plus 69 plus 31. 1 and 9, 10, carry 1, 7 and 3. So the angle, this is 180. 100 comes over here, minus 100. So angle A is equals to 180 minus 100. 180 minus 100, 80. Therefore, angle A is equals to 80. Can I mark it in the figure? So this is 80. Now, angle A is on the circle. BAC is on the circle. On which arc? BC. Isn't it? On which arc? BC. Now, angle BDC, is it on the same arc BC? Is it on the same arc BC? So theorem number 10.9, what does it say? Angles in the same segment of a circle are equal. Yesterday we have seen, we have approved, we have applied, today we are applying. Right? Now, angle BAC is equals to angle BDC. Why? Reason, angles in the same segment of a circle are equal. Which theorem? Theorem number 10.9. So therefore, angle BAC is equals to angle BDC is equals to how much? 80. Because angle A, that is angle BAC. So, if this angle is 80, this is also 80. Yesterday we have proved. Students, questions are not difficult. only you have to observe them very carefully. Nothing new. Take a look at question number 5. Again same. I am not going to solve question number 5 for you. I am going to erase this part. Right? I am not going to solve question number 5 completely. I am going to show you how it is done. You will solve it. And then if you have any doubt, you may ask. Question number 5. It says in the given figure, A, B, C and D are the points on 4 points on the circle. So these are the points A, B, C, D. This is the line. BC, it is not a diameter, as you can see, it is not passing through the circle, and this is A. A is connected to C, and B is connected to D. This is D, and this angle is, this point is E. This is 130 degree. Definitely, this 130 degree is not on the circle. Definitely, this 130 degree is not on the center, because E is not the center of the circle, and the question is not given to us. Then, sir, what is given? Check, one more angle is given. This angle is given to us 20 degree. Only this much. This is. So check. Very easy. If this is 130 degree, can we see this is a straight line? What is the sum of angles on a straight line? 180. From 180, 130 subtracted to how much is this angle? 50 degree. Then take a look at triangle DEC. What is the sum of angles in a triangle? 180. From 180, 50 is gone, 30, 70 is gone, 50 plus 20, 70. 180 minus 70, 110. So how much is this angle? 110. And this angle, observe it. Where is this angle? On the circle. On which arc or on which segment? D. One line goes to B, one line goes to C. So is this the arc? On this arc, do you find any other angle? Yes. Which from B, one line is going towards D, one line is going towards A. From C, one is going to D, one is going to A. So are both these angles on the same segment? Yes. So this is 110, this is also 110. Angle in the same segment of a circle are equal. Clear? So question number 3, 4, 5 we have discussed. Take a look at question number 2. Again you can do, but the figure is not given to you in this question. What does he say? A chord of a circle is equal to the radius of the circle. Figure is not given. You have to draw the figure. I am drawing it for you. You can copy it later on. A chord of a circle is equal to its radius. So this is the radius, say A, and this is the chord, say B. This is radius R, this is also R. They are equal. Yes, they are equal. He is telling you that the chord AB is equal to its radius. Now, if I join O to B also, what is this OB? Sir, radius. So are all the three equal in this triangle? Yes, sir. What kind of a triangle? Equilateral triangle. All three sides are equal. In the question it was given, radius is equal to chord. I am repeating again. Radius is equal to chord. Right? Now, if these two are equal, I draw it another radius. So it is what kind of a triangle? Equilateral triangle. And if it is an equilateral triangle, are all three angles equal? Yes. Each of these angles is how many degrees? 60 degrees. I am not going to solve it, I am helping you out over here. Each of these angles is how much? 60 degrees. We all know. We all know that. Now read the question. Now read the question. That is important. It says, find the angle subtended by the chord, which is the chord AB, at a point on the minor arc and also at a point on the major arc. Which is the minor arc? The smaller arc. So this is minor, this is smaller, A and B. Can you see this arc? This is minor. And which is major? This is major, sir. This is the major arc. On the very first day of this chapter, we have discussed minor and major. So he says, find the angle subtended by this chord on a minor arc. So that is this angle. So this is the angle. This angle is talking about, I'll call it P. Angle APB. That is the angle subtended by the chord on the minor arc and angle subtended by this chord on the major arc. Any of them, I am drawing it like this. This angle and this angle he wants us to find. Very, very good question. You can solve it. We have already discussed this angle. Now observe, observe, observe. I said observe, observe and observe. See, this angle O is on the center. Angle AOB. On which arc? AB. On this arc there is another angle. Angle ARB. The angle at the center is double of this. Angle AOB is twice of angle ARB. Which theorem? Theorem number 10.8. We have applied the same theorem. Angle at the center is double the angle on the circle because it is on the same arc, subtended by the same arc. How much is angle AOB? Sir, 60. Twice of angle ARB. 62 is in multiplication, goes in division. 60 by 2 is equals to angle ARB. So 60 by 2, 30 is equals to angle ARB. First answer. This is 30 degree. Now check ARBP. Is it a cyclic quadrilateral? A is on the vertex, A is on the circle, R is on the circle, B is on the circle, P is also on the circle. So ARBP is a cyclic quadrilateral. Now ARBP is a cyclic quadrilateral. So therefore angle A plus cyclic quadrilateral gives what? Opposite angles give the sum 180. So angle R plus angle P is equals to 180. How much is angle R? 30 degree. Angle P we have to find. So angle P is equals to 180 minus 30. 180 minus 30 is how much? 150. Very, very important question. I have solved almost everything. You just have to write it. Clear? Very, very important question. First, second, third, fourth, fifth we have discussed. Question number 6. Question number 6 is also the same. ABCD is a cyclic quadrilateral. Again, he is talking about cyclic quadrilateral. What is cyclic quadrilateral? Where opposite angles give the sum 180. So he is saying that